Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over how to identify your Arrhenius acids and bases. So let's get into this. So we're going to go through a few example problems where I'm going to show you how to identify whether you have Arrhenius acid or a base, and then we have to from there figure out whether it's a weak acid or a strong acid, a weak base or a strong base. So the first thing, in order to identify something as an acid, you have to know what an acid looks like and the name. So here I have some formulas, some names. First of all, acids are usually identified in the formula as by the fact that they begin with hydrogen. So almost always is the case that if your formula begins with hydrogen, it's going to be an acid. Okay, and then there's those two kinds of acids. There's the binary acid where you have hydrogen plus one other element, or it's an oxyacid where it has hydrogen with a polyatomic ion. Okay, the other way to know is if you're given the name, the obvious thing is that it's going to have the word acid in the name. So that's a dead giveaway that you've got an acid if you got the word acid in the name. Make sense? Good. Okay, so for bases, you have to know what a base is. You have to identify it. A lot of times it's going to have hydroxide ions in the formula. So hydroxide is an OH minus ion. So that's a giveaway that it's a base. If it has hydroxide in the name, that's a giveaway that it's a base as well. And we'll talk about others that are not so obvious. Um, Now, with that said, you also have to know the difference between the strong and weak acids and bases. The distinction between a strong base or acid and a weak base or acid is basically whether it's going to ionize or dissociate completely in water. So, strong acids and bases ionize or dissociate completely in water, almost 100%. So they're going to completely ionize if it's an acid, or dissociate if it's a base. Um, but if it's a weak acid or base, very little of it is going to ionize or dissociate in water. It's going to pretty much stay together, except for a little tiny bit is going to ionize or come apart, dissociate in water. And so you got to know what the strong acids and the strong bases are, and there's a list, so you got to memorize the list. Anything on the list would be a strong acid or base. Anything that's not on the list is going to be a weak acid or base. And fortunately, those lists are short. So for your strong acids, the list is HCl, HBr, HI, and then you have nitric acid, HNO3, and then you have sulfuric acid, H2SO4, and then you have your perchloric acid and your chloric acid. So that would be your HClO3 and HClO4. So that's your list. There should be 7 on that list, right? So outside of that list of strong acids, those are going to be weak acids. If it's not on the list, it's a weak acid. For the strong bases, those are going to be your hydroxides that have your metal, your group 1 or group 2 metal ions in it. Not all of them, but so here's, for example, if you go down the list of your group 1 metals like lithium, sodium, potassium, and then followed by, rubidium, and I'm forgetting cesium. Yeah, so cesium. So those metals with the hydroxide are going to be strong bases. And then you've also got your calcium hydroxide. So we're looking at the group 2 metals now. So group 2 metals would be calcium. So calcium hydroxide. And then you have what's another, barium hydroxide and strontium hydroxide. So those 3 would also be strong bases. So those would be a list of your strong bases, and anything that's not on that list is going to be a weak base. Okay, so let's apply this to our list here. So for A, We have H2SO4. You notice it begins with hydrogen, so this is an acid. Also notice that it's an oxyacid because it's got hydrogen with a polyatomic ion. So this is an Arrhenius acid. Oh, and by the way, I should define what I mean by Arrhenius acid because there's three different definitions of acids, maybe more. The definition for an Arrhenius acid is any substance that increases the concentration of H plus in your solution. H plus being your H plus ion being tied to acidity of your substance, right? So if your substance raises the concentration of H plus, then that's going to be an acid. If it's an Arrhenius base, then anything that raises the hydroxide concentration of your substance or of your solution is going to be an Arrhenius base. So Arrhenius acids increase H plus concentration. Arrhenius bases increase hydroxide ion concentrations. Okay, so obviously this is going to be an acid because when you put this in water, it's going to increase the H plus concentration because it's going to give off H plus from the formula. Now the question is this a strong acid or a weak acid? So one, we're going to say this is an acid, right? Is it strong or weak? H2SO4 is on the list for strong acids, so it is strong. This is sulfuric acid. Okay, oxalic acid. What is that? It's an acid because it's got the word acid in it. So this is an acid. Is it a strong acid or a weak acid? In this case, oxalic acid is not on the list of strong acids, so therefore it must be a weak acid. And again, we're talking about Arrhenius acids. So this would increase the concentration of H plus in your solution. Okay, what about sodium hydrogen carbonate? So NaHCO3. This one might be a difficult one. So we have an ionic substance and we have hydrogen carbonate as one of the ions. So whenever you're given an ionic compound with either carbonate in it or hydrogen carbonate in it, that's going to be a basic solution. That's going to be a base. So here, even though it has hydrogen in front of it, it will act as a base, mainly because the acid from which it comes is carbonic acid. So if you throw this in water, it's going to release an H plus, and then you'll have the hydrogen carbonate left over as an ion. So then this ion can react with water, right? So here's H2O. This can react with water, right, to take away a hydrogen from the water. So then you'll end up with an OH minus ion, and then you get back the H2CO3. So it can take a hydrogen from water, and then you've got hydroxide. So then this would be increasing the hydroxide ion in the water, which is the definition of Arrhenius base. So this can act as a base. So this is going to be a base. So this is going to be a base. And since it's not on the list of strong bases, there's no hydroxide here. So this is going to be a weak base. Potassium hydroxide. So obviously it's got hydroxide in the name, so that's a giveaway that it's a base. So the formula is KOH. So this is a base. Is it weak or strong? Well, it is on the list of strong bases. Remember the group 1 metals, lithium, sodium, potassium, rubidium, cesium, those metal ions forming a hydroxide compound those are going to be strong bases. So this is strong. HCl, again, here we have hydrogen beginning here within our compound here. Especially if it's got aqueous after it, that's going to be a giveaway that this is an aqueous solution of HCl, which means it is an acid. And notice there's no polyatomic ion here, so this is a binary acid. So it's made up of two different elements. One of those elements is hydrogen, of course. The other one is some other element, usually a halogen like chlorine. So we have an acid. Is it strong or weak? HCl is on the list of strong acids, so this is a strong acid. And then finally, ammonia. Ammonia may be a tough one. You might not be that familiar with ammonia. So ammonia is a base. So why? What's the formula for ammonia? Ammonia is NH3. The way it looks, if you write the Lewis dot structure, hydrogen here, this is going to react with water, right? So you have H2O. These electrons are negative. They really want a positive hydrogen. So remember, the hydrogen's on water. Because the oxygen is electronegative, it's taking the electron density away from the hydrogen, making them slightly positive. So these electrons are going to be very attracted to the hydrogen here. So they're going to take a hydrogen from the water, and you're going to form, so you're going to form this. So it's got a plus charge on it. So if I write the Lewis dot structure correctly, so now it's got this. This is your ammonium ion, NH4 plus, and then you have OH minus left over. So ammonia, if you put ammonia in water, it will increase the amount of hydroxide in solution, which fits the definition of an Arrhenius base. So ammonia is a base. And so, is it strong or weak? Well, ammonia is not on the list of strong bases, so it must be a weak base. And that, ladies and gentlemen, is how you identify whether or not you have Arrhenius acid or base, and whether that acid or base is strong or weak. I hope you enjoyed this video. If you did, then please, by all means, like the video, share the video, hit that like button over there, and also subscribe to my channel, hit that notification bell. When you do, make sure you click all so you can be notified by all the videos I put out. And then finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. If there's something, a concept or a topic you want me to go over in a video, or if there's a problem that you need help with or a question you need help with, then please, by all means, put that down below in the comment section, and I would love to do that video for you. Thanks for joining me, and have a great day.